We've been talking about functions and their domains and ranges. If you have a function as a set of ordered pairs, the domain is the set of all first coordinates, and the range is the set of all second coordinates. If you think of a function as being made up of points on a graph, the domain is the set of all x coordinates of those points, so how far to the left to how far to the right, and the range is the set of all the y coordinates of those points, so how far down to how far up the points go. Now, going back to our example of dollars earned as a function of hours worked, we just had these 5 specific pairs of numbers, but what about the general pattern here? What rule do these all follow? Well, it turns out that what these all have in common is that the second coordinate is equal to the first coordinate times 11.25. So that would be, if you were making $11.25 an hour, you could go from hours worked to dollars earned just by taking the number of hours and multiplying by 11.25. So you could do that for any number of hours, and we'd get a function made up of not just these specific 5 pairs of numbers, but all possible pairs of numbers where you take the first coordinate and multiply it by 11.25 to get the second coordinate. So another way of specifying a function is by giving the rule that tells you how the second coordinate depends on the first coordinate. Here the rule is you get paid $11.25 for each hour you work, or your pay is $11.25 times the number of hours. Another way to write that is with an equation or a formula. P of h equals 11.25 times h. Notice how I pronounced that. I said P of h. P stands for pay, h stands for hours, and P is a function of h. So this equation here tells exactly how P is a function of h. P is 11.25 times h. So h stands for a number of hours, and then P, to go along with that h, would be 11.25 times that number of hours. If we replace the variable h with some specific number, like 20, then P of 20 would be 11.25 times 20, which works out to be 225. P of 13 would be 11.25 times 13, which would be 146.25. So here, the domain of this function is the set of all the numbers that h can be. Everything you can put into this formula in place of h. And the range would be the set of all the numbers that P of h could turn out to be. Everything that you can get out of this formula. Now, just mathematically, h could be any number. You can take any number, no matter how big or small, and multiply it by 11.25. But practically, there's an upper limit to how many hours you can work. So it wouldn't make sense for h to be 35 million. And it probably wouldn't make sense for h to be a negative number. So if the domain is everything that h can be, we can talk about what makes sense to do the calculations on, or we can talk about what makes sense in terms of the actual situation. In that case, the domain would be all possible numbers of hours that a person could work, anywhere from 0 up to the maximum possible number of hours in a pay period. So unless there's some specific context involved, the domain of a function is everything that you can put in for the variable that the function depends on. If you just have a formula for that function, and you're allowed to plug in any number that that formula works on, the domain is everything that you can plug in. So how about a function like f of x equals 9x plus 5? This means this function takes whatever number you give it and outputs 9 times that number plus 5. Are there any restrictions on what x can be? Are there any numbers that you can't do that to? Nope. You can do that to any number. You can take 9 times any number and add 5 to it. So the domain is all real numbers. Now what about this example? G of x equals x plus 2 divided by x minus 10. So here's a function where whatever number you give it, it takes that number and gives you that number plus 2 divided by that number minus 10. It'll try to do that to any number you give it. But are there some numbers that that won't work with? Are there any restrictions on what x can be? Yes. The denominator can't be 0 because then we would get a division by 0 error. So the domain is all real numbers except 10. We don't want to put 10 in for x because then we would get 10 plus 2 over 10 minus 10, which would be 12 divided by 0, but that's undefined because you can't divide by 0. So this function doesn't work if you try to put in 10 in place of x. It's undefined there. It works for any other number, so the domain, the set of everything it does work for, is all real numbers except 10. For the rest of this video, we're going to be practicing with function notation, plugging numbers in and evaluating the function. In this example, we have a function that represents the charge for delivering a truckload of gravel. A gravel dealer charges $50 plus $30 per cubic yard for delivering a truckload of gravel. So to write that as a formula, we can say C of x equals 50 plus 30 times x. So here the x stands for how many cubic yards of gravel, and then C of x stands for the charge for delivering that many cubic yards of gravel. C is a function of x. The charge is a function of the amount of gravel. So what is the charge for delivering 3 cubic yards of gravel? That is, what is C of 3? Well, if we replace the x in this formula with the number 3, do to 3 what the formula says to do to x, we're calculating 50 plus 30 times 3. And that would be 50 plus 90, which is 140. So, $140. What about for 10 yards? Now we're evaluating C of 10. And that would be 50 plus 30 times 10. 50 plus 300 is $350. What about for 20 cubic yards? If we put 20 in for x, we're calculating C of 20. So that would be 50 plus 30 times 20. 50 plus 600 is $650. In this next example, x and f of x don't really stand for anything in particular. This is just kind of a practice example for how this function notation works. So f of x equals 5x plus 1. That means if we have f of something, what we do is we take 5 times that something plus 1. So to find f of 2, we're putting 2 in place of x. We're doing to the number 2 what this says to do to x. So we're taking 5 times 2 plus 1, which would be 10 plus 1, or 11. What about f of 10? Well, that would be 5 times 10 plus 1, 51. What about f of 0? 5 times 0 plus 1 would be 0 plus 1, which would be 1. What about f of negative 1? That would be 5 times negative 1 plus 1. So negative 5 plus 1 comes out to negative 4. What about f of w? Well, that would be 5 times w plus 1. There's nothing more to do there. F of smiley face would be 5 times smiley face plus 1. Whatever's in the parentheses here, we just put it in place of x. F of b plus 1 would be 5 times b plus 1 plus 1. And we can simplify that a bit, because if you take 5 times b plus 1 and multiply that out, you get 5b plus 5 plus the 1 on the end, so that's 5b plus 6. F of 5n would be 5 times 5n plus 1. And then 5 times 5n would be 25n, so that's 25n plus 1. Here's a different function. This is g, and it takes whatever number you give it for x and gives you that number squared, that is that number times itself, plus 2 times that number, plus 10. So g of 3 would be 3 squared plus 2 times 3 plus 10, which would be 9 plus 6 plus 10, which equals 25. So g of 3 equals 25. G of 0 would be 0 squared plus 2 times 0 plus 10. And that would be 0 plus 0 plus 10, which would be 10. And g of negative 2 would be negative 2 squared plus 2 times negative 2 plus 10. So negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. And then 2 times negative 2 would be negative 4. And 10 would just be 10. And then when we add 4 plus negative 4 plus 10, we get 10. So g of negative 2 equals 10.